Okay, how you doing? I've got two equations written up here. The first equation is an absolute value equation. The second one is a equation with parentheses. Parentheses are not absolute values. So, parentheses allows you to distribute through, okay? So that I can say that this is 3x plus 4 equals 27. You're not allowed to do that with absolute values, okay? Because the absolute value has two answers, and if you start distributing through, you're going to change your answers, and that's not okay. So, what I have to worry about here is because there's multiple answers, I can't go ahead and distribute. What I actually need to do here, okay, is I need to remove the multiplication from the absolute value. And in this case, okay, we can think about it as the same idea, and I don't know if your teacher explained this to you, but an expression always represents one number. If I knew, okay, taking a look at this x plus 4, that's my expression in the term. That is my quantity of x plus 4. And I'm taking my algebraic expression and multiplying it by 3. Well, this algebraic expression right here is just one number. So 3 times what is 27? When I look at it with parentheses, 3 times what positive number gives me 27? I know right now that it's 3 times 9. That makes 27, okay? But this says x plus 4. So what number do I plug in for x that makes this expression 9? Well, it's 5. 5 plus 4 is 9. So 3 times 9 is 27. Therefore, the x number that I had, the x variable that was plugged in for was 5. Okay? That's one way of thinking about it. We need to think about this in that sort of same manner. Okay? 3 times the absolute value of what number is going to give me 27? Well, the thing that doesn't change here is that I still have to do 3 times 9, because a positive times a positive, the only way I get another positive. But remember the absolute value. Okay, this is the important thing of it. Okay, the absolute value. Thinking about this problem, 3 times what? Okay, the absolute value of what gives me 27. So here we go. You knew that it has to be 9. Okay, so I have to do 3 times 9. So 3 times 9. So what values? Okay, so again. What value, absolute value here, is going to tell me 3 times 9. So what number is 9 units away from 0? So 1, 2, 3. Let me write that. It's going to be a little bit different. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's that distance, and that's negative 9. And 1, 2, 3, 4, 5, 6, 7. Okay, 8, 9. And I have this, and then there's my other distance. Okay, they're equidistant. I didn't draw them up very well. But this is positive 9. Okay? And the thing that I want to point out to you is that this value of x plus 4 must be equivalent to giving me negative 9 or positive 9. All right? And the way we go about solving this is that I can't distribute this 3 like you would have done with the parentheses. What I must actually do here is remove the operation of multiplication away from the absolute value and just get the absolute value equation expression as it stands alone. So the way I do that is if I'm multiplying by 3, I need to divide by 3. So I divide by 3, I divide by 3, and what you're left for is take a look at this and notice some instances here. So I get absolute value of x plus 4 is equivalent to, what's 27 divided by 3? It's 9. So go ahead and take a look at that. So there's that, there's a reason these things, okay, work out to be that they do. So I get x plus 4 equals 9. So, again, now what we're saying to you is that x plus 4 could be, if I plug in a number for x and add 4 to it, it better produce me an answer of positive 9 or it better produce me an answer of negative 9. Because those are the two values that are 9 units away from 0. So, what number can I plug in here that gives me positive 9? And what number can I plug in here that gives me negative 9? So we can just set up equations for that instead of just sitting here guessing and checking. Okay, because sometimes these are going to get a little bit more longer. Okay, I can come up here and go x plus 4 better give me positive 9, or x plus 4 better give me negative 9. So then when I go ahead and solve these, I would subtract 4 from both sides. So 9 minus 4 is 5. So I get x equals 5. Okay, and in this case, I subtract 4 from both sides. So negative 9 minus 4 is x equals negative 13. So now I go back and check again. And I take this all the way back into the original problem. And let me get rid of these divide by 3's. Okay? But 5. So if I stick 5 into here, into this expression, it better simplify to 9. So 5 plus 4 equals 9. Absolute value of 9 is 9. 3 times 9 is 27. Done. Perfect. Check. Good. Grand. So here we go. Negative 13. Negative 13 plus 4 is negative 9. But that's okay, because we're going to take the absolute value of that. Absolute value of negative 9 is positive 9, and positive 9 times 3 is 27. So again, with these absolute value problems, you have to understand that you have to get the absolute value by itself to figure out what number does that absolute value expression have to simplify to give you the value that is that amount of units away from 0. Let's make a hard one. Let's make it as hard as we possibly can. Okay? So, the hardest one that I personally, if I was your teacher, would ever give you is something like this. So I would go for absolute value of x, and I would say 2x minus 6 and plus, let's go 8, and that's going to be equivalent to 48. Okay? So, here we go. I've got this expression, and I need to think about this for a second. 4 times what number, then add 8 to it, gives me 48. All right? 4 times what number plus 8 gives me 48. So if I started going through my times tables and adding 8 to it each time, which one of those is going to give me an answer for 48? And in this particular case, I would hope that you know that 4 times 10 is 40. Add 8 to it, you get 48. So this better be a 10. So inside here, this better get 10. And when I go through and simplify my operations, I better get the absolute value of 2x minus 6 is equivalent to 10, because it has to be. So here we go. We simplify this much like we would simplify anything else, except you have to remember that absolute values do not hold the same properties that parentheses do, and therefore you cannot do distributive property. So I must undo all my operations without doing distributive property. So I must get rid of this positive 8 before I get rid of that 4. So we're going to go ahead and go minus 8, minus 8. So I get 4 times the absolute value of 2x minus 6 equals 40. Okay, remember we talked about that idea of 10. So right here I have 4 times the absolute value. I can't distribute, so don't do it. So how am I going to break apart the multiplication of 4 and the absolute value? I'm going to divide by 4. So if I divide by 4, I get the absolute value of 2x minus 6 must be equivalent to 10. Now I'm not done. Okay? And the important thing here is to recognize that you're not done. And the only thing that you've done here is you isolated it to the point where you have the absolute value of 2x minus 6 must be 10. So using this number line again, okay, what you've discovered is that 0, if I went 10 units left, I would be at negative 10. And if I went 10 units to the right, I must be 10. So what this is saying is that this distance right here is also going to be called 2x minus 6, okay? And that this distance here can also be represented by 2x minus 6, because they're the same, because it's a distance, it's from 0. Well, if this is 2x minus 6, then that right there gives me negative 10, and on this side, 2x minus 6 would give me positive 10. So the way I do this is I set the problem up, and I start solving for it. So I come over here, and I'm just going to erase some of my work here. Okay, I'm just going to erase this bottom part. All right, so I hope it doesn't bother anybody, but I get the absolute value of 2x minus 6 must be equivalent to positive 10, or I get the absolute value, or I get 2x minus 6. Sorry, I got rid of the absolute values now. Okay, 2x minus 6 must be 10, or 2x minus 6 must simplify to negative 10. It has to happen that way. You've got no choice at this point, because we've just talked about 4 times 10 plus 8 would give me 48. So this absolute value must be negative 10 or it must be positive 10, because those are the ones that are 10 units away from 0. So I'm just going to go ahead and solve this. So add 6 to both sides, add 6 to both sides. You get 2x equals 16. Divide by 2, you get x equals 8. So x being 8, that if I plugged 8 into here, then it would simplify to give me positive 10, or in this case, positive 10. So 2x minus 6, so if I add 6, I get 2x equals negative 4. divide by 2, I get x equals negative 2. That now if I plug negative 2 into here, it gives me negative 10. So let's go ahead and do that. So 2 times 8 is 16. 16 minus 6, positive 10. Absolute value of positive 10 is positive 10. So 4 times 10 is 40 plus 8, 48. Perfect. This one, negative 2. If I plug it into the original statement, 2 times negative 2 is negative 4. Negative 4 minus 6 is negative 10. The absolute value of negative 10 is positive 10. So 4 times positive 10 plus 8 is 48. And that's it. So I hope you understand that when you're doing these problems, you must simplify for the absolute value, and then you set that absolute value, whatever that expression is, equivalent to the positive number that you have on the right. So in this case, we had this 10, and the negative value, because remember how I drew those number lines in, that it must be equivalent to. So thinking about over here, that I got to this step, that the absolute value of 2x minus 6 equals 10. That's where I got, and then I drew the number line in. And I went to 0. I said 10 units to the left is negative 10. 10 units to the right is positive 10. So this 2x minus 6 must simplify to being negative 10 because it's the absolute value, so it's 10 units away from 0. And 2x minus 6 must represent positive 10. And that's why we set up these two equations, where 2x minus 6 equals 10, and 2x minus 6 must be negative 10 to figure out what is that x value that I plug into this that simplifies this expression to 10 or negative 10. So I hope that helps with any of the problems that you're going to practice.